أبنائي وبناتي من طلبة المرحلة الثانية، السلام عليكم ورحمة الله وبركاته. Today we have the lecture 1 in specialized embryology, the development of gastrointestinal system. Look at this picture. This picture is for the embryo at week 3, while this picture is for embryo at week 4, which illustrate the folding of embryo due to the development of GIT. What are the objectives of lectures in GIT development? To understand the followings: the germ cell layer contribution to the early gastrointestinal tract, the folding of the gastrointestinal tract, the three main embryonic divisions of the GIT, the associated organs development, which are liver, pancreas, spleen, and the mechanical changes or rotations during the GIT development, and finally to understand the gastrointestinal abnormalities. Introduction. The gastrointestinal tract arises initially during the process of gastrulation from the endoderm of trilaminar embryo at week 3. It extends from the buccopharyngeal membrane to the cloacal membrane. So the GIT is arising from the endoderm at the week 3. The tract and associated organs later have contribution from all of the germ cell layers. Look at this picture. Here is the formation of the trilaminar germ disc, ectoderm, mesoderm, and endoderm. The endoderm is responsible for formation of the gastrointestinal tract. Again, this is the picture illustrates the contribution of endoderm to formation of digestive organs and the lungs. This picture illustrates the early GIT tract, which is forming a tube from the buccopharyngeal membrane to the cloacal membrane. During the 4th week, 3 distinct regions, foregut, midgut, and hindgut, extend the length of the embryo and will contribute different components of the GIT. The large midgut is generated by lateral embryonic folding, which pinch off of the pocket of yolk sac. So the two components communicate through the vitelline duct. Look at this picture, the yolk and then formation of foregut and midgut and hindgut. And here is the connection between two compartments between the GIT and the yolk through the vitelline duct. So here the folding of the embryo is seen. The 3 divisions are also later anatomically defined by the vascular arterial supply to each of these divisions as the celiac artery and superior mesenteric and inferior mesenteric for each part of the GIT. The embryologic development. The mouth or oral cavity is formed following the breakdown of the buccopharyngeal membrane, which is called also oropharyngeal or oral membrane, and contributed to mainly by the pharynx lying within the pharyngeal arches. Loss of the buccopharyngeal membrane opens the tract to the amniotic fluid through the remainder of the development and during the fetal period is actively swallowed. This picture showing the human head with feature of the buccopharyngeal membrane breakdown. The first part of GIT is the foregut. From the oral cavity, the next portion of the foregut is initially formed, which is the pharynx. Then the formation of a single gastrointestinal part, esophagus, and respiratory trachea as a common tube that lies behind the heart. The respiratory tract will form a ventral bud arising at this level. So the foregut and the trachea begin as a common tube. This is a lateral view, while this is a ventral tube. Here is the opening of the respiratory diverticulum, and here is the opening of the foregut. They are common tube. Then there is a septum, which is between the trachea and the esophagus, to separate the common opening into two openings for the esophagus and the trachea. So during the 4th week of development, the formation of respiratory system takes place, and the respiratory diverticulum arises as outgrowth from the ventral wall of the foregut. Then it is separated from the foregut by formation of septum called esophageotracheal septum. So this septum will divide the foregut into two portions: dorsal portion, which means esophagus, and ventral portion, respiratory diverticulum, which giving rise into the trachea and lung buds. The diverticulum remains in an open connection with the pharynx upward through the laryngeal orifice. So there is a common opening and then separation by the esophageotracheal septum to forming opening of the esophagus and another opening for the trachea. So the part of the foregut cranial to the side of origin of laryngeotracheal groove, forming the part of oral cavity and the pharynx, while that caudal to the laryngeotracheal groove, forming the esophagus and stomach and upper half of the duodenum. This figure illustrates the region of the laryngeotracheal groove, which is the landmark for embryological development of the foregut. Development of esophagus. We have 3 stages for development of esophagus. Number 1, from the foregut caudal to the opening of the laryngeotracheal tube, the esophagus develops as long and narrow tube. Then there is a proliferation of its epithelial lining, lead to temporary obliteration of its lumen. And the third point or third stage, which is rapidly becomes as recanalization of the esophagus again after short time. So we have 3 stages. Number 1, formation of the esophageal tube caudal to the opening of the laryngeotracheal tube, and then a proliferation of its epithelial lining, lead to temporary or transient obliteration of lumen, and stage of recanalization of the tube. Congenital anomalies of the esophagus. What are the congenital anomalies of esophagus? Number 1, there is incomplete recanalization, and this leads to esophageal stenosis or narrowing. Again, there is maybe esophageal atresia due to complete failure of recanalization, and this leads to its obliteration. So esophageal atresia may happen due to complete failure of recanalization, and that leads to obliteration of the esophagus. The third anomaly is the presence of abnormally short esophagus. The fourth anomaly is due to a presence of patch of epithelial lining of the esophagus, which may differentiate into gastric mucosa that secretes HCl and lead to ulceration of the lower part of esophageal mucosa. While there is another feature of anomalies which is called tracheoesophageal fistula due to the failure of the separation. Here, this figure illustrates the types of tracheoesophageal fistula. This is the commonest type, where is an proximal blind end of the upper part of esophagus. And here is the tracheoesophageal fistula between the distal part of esophagus and the level of bifurcation of the trachea. While the figure B illustrates both atresia in the proximal and distal part of esophagus. Here there is a common communication between the proximal part and distal part of esophagus with the trachea at the level of the bifurcation. While here is the communication between the proximal part of the esophagus to the trachea with the blind and distal part of esophagus. And here also there is a communication between upper part and distal part of esophagus with the trachea, but opened in separate opening for each of them. The type illustrated in figure A is the commonest type. So here there is obstruction of the proximal part and communication between distal part with the trachea at the bifurcation of the trachea. Tracheoesophageal fistula may lead to several clinical manifestations to the baby as 3 C's: choking, coughing, and cyanosis. What are the steps for diagnosis of esophageal anomalies? Besides the clinical manifestations, which is needed. This figure illustrates the oblique barium esophagogram, demonstrates fistula arising from the anterior esophagus extending superiorly to the trachea. While here, feature of the esophageal atresia is seen. This figure illustrates that we have 2 communications between the esophagus and the trachea.